entire internet is fucked up. You might want to be careful.
Yeah.
Oh, is this pointing this way? Okay. So is it the screen and this, or is it just coming from the camera? Oh my God! This is sci-fi. Hi everyone.
Okay, perfect. Right. Okay, we're starting. Where is it?
I think someone's in the toilet and then two are probably in the lounge. Or...
Hard to see everyone at the back of this room, isn't it?
Yeah.
Hi everyone.
We'll just get a start. So if you want to do just a wee intro, and then we'll, yeah.
Okay.
Neil as well. Tell Neil we're starting.
Yeah. Do you want me to just go shout in the next room? I'll do that.
Yeah, we'll probably squeeze a few more people in.
Yes.
You need to remove P. There was a month in an AI talk, and like 40 odd people showed up.
I actually, oh, that's me. I actually thought about not using the letters A or I in this talk at all.
Really? You got AI there.
Yeah.
P in the middle.
Yeah.
Okay, we're ready. Right, whenever you're ready. Okay, cool. Right, whenever you're ready.
Good evening, everyone, and everyone joining remotely. I'm going to be talking about FastAPI. This is a preview of a talk that I'm going to be giving at PyCon Lithuania next week. So feedback at the end is very much appreciated, unless it's really harsh, in which case just keep it to yourself. Yeah, who's heard of FastAPI? Who has used FastAPI? Okay, great. So this is going to be a little bit of an introduction and overview of FastAPI, just so that everybody understands what it looks like. And then I'm going to look at some of the features of the framework that have been really good, that I've really liked. And then I'm going to show some things which have been less helpful, some gotchas that have been problematic or we've had to work around. So if you've never used FastAPI, then you will have used Flask or Express or Sinatra. And these are all micro frameworks with a design which maps a URL path and an HTTP method onto a function or a method that handles that. I was trying to find out the history of this, and I think there's actually a Ruby library called Camping, which is the first one to have this micro framework design. Sinatra was the one that, for me, was the one that popularized it, and then Express became very popular as well. But yeah, if you will have used one of these, and so the syntax is going to be very familiar to you. You've got an application, you've got the path slash, and then this is returning a string from that. So very easy to understand. So the features that I really like in FastAPI, type hinting, I think it's really good. The async support, very useful. Dependency injection, I don't want to spoil this, but it's possibly my favorite feature. And then the testing support in FastAPI as well, I think is really good. So the type hinting, this is our basic app from before, but we've added a type hint in there. So FastAPI was the first proper use of Python type hinting that I saw as being really useful. When type hinting first came out in Python 3, and I tried it on a small project, and I felt like it wasn't really giving me any benefits. You know, if you're used to writing Python, you're used to not really having to worry about the types. You're trying to use things in the way that they should be, and if it's not there, if it's not the right type, then you rescue yourself from that. And this, having MyPy running against this small code base didn't really seem to be giving me any benefits. And I actually ended up running into a bug with JSON typing, and I just ended up turning off the typing validation, because it just wasn't really giving me anything. But FastAPI this was the first time I actually saw the types being used. So you can go even further, because this is only returning hello world, so you can actually annotate it with the string that you're returning. And what this gives you is an automatic schema for your API. It finds all the paths, and it finds the possible responses from there, and it looks at what these functions can actually return, and it puts that into a schema. So in this case, we've just got a slash. It's always going to return a 200, and it's going to be a string, and it's going to be a constant, which is hello world. And this is great. This is really useful. Not for me. I don't tend to go and read the JSON schema, but it gets plugged into a docs page. So I don't really like writing documentation, and having automatically generated API docs, which you can actually then use like a UI, is really awesome. And the fact that this is actually using the types from your code to generate these docs to show you what the outputs are going to be, then this is really awesome. And this is great for communicating with your users as well. If you've automatically got your page of docs, say, hey, what's the latest feature? It's this section in the API docs, and people can actually see that. There's this. You get the inputs and you get the outputs there as well, and we'll see that in a more complex example. We're using Pydantic here. Pydantic is bundled in with FastAPI, and FastAPI uses Pydantic for inputs and for outputs as well. So in this case, we've got a slightly more complex path, which takes a parameter. So that gets injected into that function, and then this is sent as the body of the put request. And then this is the payload that's defined up here. And you can see we've got a size and we've got a tags, but we've added in type hints for both of these. So the tags is just a dictionary of string to string. The size is an integer, but we've wrapped the integer in this annotated type, which comes from the typing package, and then we've annotated that with a field from Pydantic saying it's got to be greater than 1 and less than 1000. And then from that, we're just returning the name, the size, and the tags in another class called resource, which comes from comes from the Pydantic base model as well. So what we get is validation on the inputs, and we get a schema for the outputs as well. So this name is going to be validated as a string. I mean, that's going to be anything. We haven't put any restrictions on that, but in the same way that we had validation on the integer, we could have validation on the string as well. The request body, this is what the schema has to look like. This is what it's got to conform to. And if you don't conform to this schema, then FastAPI sends you a 422, so it doesn't even get to your function. You automatically get validation on your inputs by the way that you type that payload. And then this is the schema for the response as well. So we've only got one possible response there, but that's the schema, and that's what clients are going to be expecting. So asynchronous I/O. FastAPI is fast, and it does that through asynchronous I/O. So it supports the async def functions in Python. This is so that the input-output is non-blocking. You've got an event loop, and the requests that come in get put onto the event loop, and that means that the I/O between the clients doesn't block the rest of the events on the server, as long as you use these async functions. And FastAPI has first-class support for this, so you can await I/O within there. So this is going away and getting some data from an external URL, and at this point the event loop is unblocked and other requests can be served by that event loop. Dependency injection. So this is my favourite feature of FastAPI, possibly my favourite feature, apart from the automatically generated documentation. Where you've got these HTTP functions which are taking arguments in, one of the arguments that you can put in there is a dependency which is used within that. Again, you're using this annotated type, and you're using this depends function from FastAPI itself. And into that, you pass a function which returns you your dependency. So whatever you need to do to get your dependency, you put that into the depends function. You annotate the type of that dependency with this depends function, and when the request gets served, you end up with this dependency in here. These are cached by default as well, so if you've got quite an expensive setup, then this is cached by default. And you can have asynchronous context managers as well. So if you need to do setup and teardown with your dependency as well, and if it's an asynchronous setup, then FastAPI supports all of that as well. So you can see that we annotate the type that we want with this function which actually sets up that dependency, and that handles it all for you, and you get that injected in. So this just lets you separate out parts of your code and keep them decoupled. So you just need to decide what you need in there, and then you set that all up externally, and it gets pushed in. So of course, you can then actually decouple everything, keep the actual HTTP function very thin, put all the logic into a separate class, have something which is going to set up that class and add it into the HTTP function, and then this just becomes your contract with the outside world, with the client, and then all of your business logic is stored in something which isn't related to the framework, and you can test completely independently. Splitting it out even further, you can have different levels of dependencies. So in the actual endpoint, we want the service which is going to get the data, and that's what we care about. The service itself wants a client, so we can set up the weather service in this function, but we can inject into this function the client, and we can have the client generated elsewhere. So this makes it even more granular, even more decoupled. You can reuse this HTTP client for any other services which need it. And you can have testing at different levels. So you can inject a mock HTTP client into here to test, and you can inject a canned service in there, so you can just test the behavior of the endpoint. So testing. Yeah, I really like testing, and this isn't a talk about testing, but I'm going to use the word testing a lot in the next few minutes. FastAPI comes with a test client. So you import that and you pass your app into it, and then you can make requests to the app, and that'll give you a response. So you can then assert on the status code and the shape of the response that comes back, which is really handy. But of course, we're calling this external URL. So we want our tests to be predictable and repeatable. So we don't want to be going across the internet to some API every time we run our tests. So at some point, we want to have some kind of mock data in there. And this is where the dependencies come in. So on the app, you've got this dependency overrides dictionary, and the function that you passed to actually create that dependency, you can override it with something else. So in here, I've just created a mock service, and then I've just created a Lambda to return that mock service. So then when you test the application, you get whatever you've injected there. You're overriding that dependency, so you can inject whatever you want in there. You've got full control in your tests, and yeah, and because you've got these different levels of dependencies as well, you can mock things at different levels. You can just mock the service, so you can just test the behavior of the endpoint, or you can inject something which is just going to mock the external API and test the integration with everything that you control. So this isn't part of FastAPI, but this is really useful. This is a library called Schema Thesis, and it builds on top of another library called Hypothesis, which is for property-based testing. So what this does is this finds your OpenAPI schema, and so we've just got a setup and teardown function here, which is again just mocking these dependencies. So we're just testing the application, and then we say parameterize on this test API, and we just call and validate each one of these. And this test case is everything that it can find in your schema. So all of the endpoints, all of the inputs for that, it will crawl over all those endpoints. It will generate inputs from the schema, things which are supposed to be valid. It'll go and test those. If it gets anything back from the API which isn't documented, say you say that this endpoint returns a 422 or a 200 or a 201, and you get a 404 back from it, then Schema Thesis will throw that up. Any inputs which aren't handled properly. So it'll just look at the schema and say, oh, this can be a string. So I'm going to generate 100 different examples of a string, send it to the API, and just see how it handles it. So it's a really good way of uncovering undocumented statuses and payloads which aren't tightly specified enough. So things that haven't gone so well using FastAPI: accidentally calling synchronous code in asynchronous endpoints. So we talked about the asynchronous handling and how any I/O can be non-blocking. So when you're awaiting something, then the event loop is free to serve other requests. If you accidentally have an async endpoint and you have some kind of blocking operation on there, then that's going to block the event loop at that point. And a lot of the time you'll be running this in a single-threaded web server. So unless you've got a number of replicas running of that, then you actually wouldn't be able to serve any requests during the time that was blocking. So the more time that this runs for, and the more time that this is called, then the longer your event loop is going to be blocked for. And that can, in a big application, that can be really confusing, because it's not clear where this slowdown is coming from. You're just seeing your response times go up across the application, which isn't great. But we can detect this. So what you can do is, on the event loop, you can put something on to be called later with an interval. So I think this is just 1. And it'll run this function, and it'll pass this in as an argument. So it'll take the time that this was scheduled for, and it will then find the time that it actually starts running, and it'll take away the interval from that. So it'll find the delay between when this was supposed to start and when it actually started. So then you can find that out, and you can actually see whether or not there is a delay on your event loop. Is that where that's coming from? And then this just runs itself again once it gets to the end. So in here we're pushing it into the logs. Obviously that could be a metric that gets pushed into your observability system, so you can actually have a graph of that, and you can see where things are going wrong, and you can calculate percentiles and things like that. So the way that you hook that up is that you use this lifespan argument into the FastAPI app. You start this in this context manager, and then yield. So this allows you to run, so this lifespan function in general allows you to run things on application startup, and then run something else when the application shuts down. And in this case, you're just starting your event loop monitoring, so that runs, schedules something for a second in the future, calculates the lag, and then schedules another one again. So it's a handy place to hook up that monitoring. Worker processes. So FastAPI docs recommend using UVcorn, and that's an asynchronous web server in Python. And it does work really well. It's very performant. And when you get to the point where you need to scale it up, there's a section in the FastAPI docs on running in containers. And it says to scale your processes, leave it to your underlying container orchestrator. So if you're running on Kubernetes, as I'm sure we all do at some point, then just leave it to Kubernetes to bring up more containers. And that's kind of okay, but it does sometimes take a little while for Kubernetes to bring stuff up, particularly if it's on a node which doesn't have your image cached on it. So this running UVcorn, or even running Gunicorn with UVcorn workers, to me seems like a faster way to get that parallelization. And oops, sorry, I'm just trying to scroll down on my notes. And so you've got a couple of options for actually scaling these out. You could scale them out within the container, or you could scale them out, have the scaling done by your container orchestrator, and and they both work. They both work well, and you've got I think you pay a delay, you pay a price, and you also pay a kind of a cost for whatever else you have running in your pod. So if you've got your Python application running, plus any number of sidecars, plus maybe some init containers which run on the startup of that Kubernetes pod, then you pay that price when you scale up more, and you pay the resource cost as well with those running. Whereas if you scale the workers within your pod, within your container, then you've just got one container process running and multiple worker processes running within that. They both work, and they both work well. The downside for this is that you pay a cost for the resource of the pod itself. So the pod itself will use more memory and more CPU. So if you're setting resource limits in Kubernetes, then you have to account for that. And if you're able to parameterize the number of workers in there, which you probably should be able to, then you've got a calculation to do for the maximum amount of memory and CPU that your pod has is going to be proportional to the number of workers that you have inside there. So I ran a number of experiments with this and eventually went back to just running a single thread inside here, not least because of another problem which came up. Prometheus metrics, really easy to integrate Prometheus metrics into your FastAPI app. So you get, this is all that you have to add. One import and one line, albeit with multiple calls on it. And you get metrics being exported, and Prometheus will go and scrape that metrics endpoint, and that'll give you things like the amount of memory that Python's using, garbage collection stats, stuff like that by default. And then you can add your own, and HTTP stats for FastAPI as well. So number of requests and their status codes, so you can find out if your application's throwing 500s. Request latency as well, which may alert you to the event loop lag that we saw before. And this is great. Unfortunately, if you run multiple worker processes, then the counting for these metrics gets screwed up. And I'm not going to go into exactly why that is, because I don't know. But I know that it does. I know that it does. And when I saw this graph, it counts too many, basically. So there was this graph of a number of requests, and it just kept growing. And it was very strange. And it was only when I realized that I introduced worker processes, but hadn't looked at whether or not this was still correct, that I realized what was going on. And there is a documentation for Prometheus, the Prometheus Python client, saying if you're running multiple worker processes in your server, this is what you need to do. But I didn't do that. I just went back to running one worker process because that was easier. It was a little bit involved. You kind of have to have some kind of file cached on disk or something like that with things in it, and then you have to clear that when the server starts up, or after metrics have been collected. I can't remember. So it was a little bit more involved than I expected. So that was something which threw me. Generating SDKs and clients. Now I was trying to get a code snippet in here. This side isn't intentionally left blank, but I didn't manage to get what I needed before I started. Generating SDK clients. So you've got your automatic schema from your typing, and that's validating your inputs, and it's validating your outputs as well. Oh, it's showing you what your outputs are going to be. That generates you a lovely page of API docs, which I think we'd all appreciate. So it stands to reason that from that schema, you can generate an SDK client as well. And you can. And for simple cases, that's worked really well. You have an API, you just run it through an OpenAPI SDK generator, and you end up with a package that you can install Python, TypeScript, Go, whatever you need. You end up with a client that's going to validate your inputs before you even send them, and marshal those responses into objects within your within the domain of the language that you're working in. There are some caveats to this though. So there's different versions of the OpenAPI specification. 2, 3, 3.1 are the kind of three main recent ones. 2 isn't used so much, but there are some of the generators still mainly support 2 and a bit 3. 3.1, which is the default for FastAPI, isn't supported by all of the generators. So there are some little weird discrepancies like that. You can pre-process your OpenAPI JSON document, and that'll get you past some of those hurdles. But there are then some slightly strange bits of behavior with some of the typing in Pydantic. So the one which has tripped me up recently is where you have an optional field with a default of none. And when that ends up in a schema, there's particular versions of the OpenAPI of one OpenAPI schema generator that I use, which doesn't like that, and it throws an exception when you try to generate the client. So that's really frustrating. So on the surface, you get this automatic SDK generation from your schema, which is great, but in practice it doesn't always work. It's not always completely reliable, and so that can be quite frustrating. But to summarize, I really like FastAPI. So I first saw it about 4 years ago, and I've been using it solidly for about 3 years now, and it's awesome. So the automatic API docs. When I saw that, so you can actually, that's a Swagger page that I showed before. You can actually get redocs as well. I've looked at that like once or twice since using it, and I'm not that familiar with it, but the Swagger one is really awesome. Being able to actually exercise the API through that is great. Dependency injection, really great. Love that. The way that it allows you to decouple your code, the way it helps you with testing and focusing your tests, and like being able to run big end-to-end tests and more focused tests on just specific bits of your code is awesome. It's also used in the security handling. So it has, FastAPI has security built in, which I haven't actually mentioned in here. And it's when you have like an authorization header or something coming in, then you can have a dependency on that security header, on that authorization header, and then in your function where you're handling that, you can look it up in a database, decode a JWT, whatever you're doing, or look it up in a file or something like that. Whatever you do with that, it's just done with this dependency injection mechanism. And then, of course, from that, you can create a dependency on like a validated user or something, and you can have that in your endpoint. So it works really well. And then the data validation. This is in a huge part Pydantic, and Pydantic is another really awesome library, which since picking up FastAPI, I use in the rest of the code base as well. Just modeling your domain entities and stuff like that is really good, and having these kind of this data validation, so you've got some guarantees with this object that you're going to have this data and it's going to be in a particular format is really great. So yeah, FastAPI, I'm all in.
Nice, thanks very much for that. Okay, so is anyone get any questions at all? Oh, okay, there you go. Take that.
I had a couple. Dependency injection, heard of, never used, so some curiosities around that. And also I wanted to ask a bit about async mock, which is a bit more specific. Async mock, I was just wondering, is it basically a function that takes whatever's in the JSON and goes like, oh, so you want me to give you one of those, I'll create some mocks? So if it was ints, it'll just throw you some ints. If it's some strings, it'll throw you some strings, or is it more complicated than that?
So is this async mock?
Async mock specifically, I was wondering, is it just a function inside the FastAPI that then just finds all the endpoints of that JSON or that schema and says, give me those?
So async mock is from the mock package in the Python standard library.
Yeah.
So I've missed off this abstract service actually, but this is so the service that we had when we split this out. So you've got this async. So you've got a class and it's got an async method on it. When you pass that into as a spec to async mock, yes, I haven't shown the abstract service, which just declares that as an abstract base class. When you pass that into async mock, then it automatically takes care of the return value for this, because this has to be a coroutine. So this has to be awaitable.
So it's literally looking at whatever you gave it, in this case, abstract service, and that class or that object will then have a bunch of data types on it, and it'll then go, oh, so you need one of these, one of these, one of these, and it'll generate those randomly, or?
So it'll behave like a normal mock or magic mock.
Right.
So if you don't put anything on there, then it'll return a magic mock or a magic mock from that function call.
Okay.
But any that are async, it'll make them awaitable.
Got
So
it.
it'll be an awaitable magic mock.
As if that's dependent on that, then it'll make it. Okay,
Yeah.
cool. And I think with the dependency injection, I think I get it. Like I say, it was the first time really kind of walking through it. But my main thought was what it looked like you were giving it was like a variable name and typed sometimes, and then a function that would return that type. Am I right in thinking that weather service is a thing that get weather service will return? So with annotated, you're basically saying give me a weather service, which is the output, i.e. depends upon the output of get weather service.
Yes, exactly.
Yeah, cool, perfect.
Yeah.
Nice one.
Yeah, so the annotated type, that's from the typing package, and this is used to attach things to types. So the int here, which is constrained by these upper and lower bounds, that information's attached to this type with the annotated type hint, and this is I can't remember what version of Python it is. Maybe 3.10. This got introduced. So in the earlier versions of Pydantic, they actually had their own internal type called constrained int or something like that, and that took things like that. And then they've made this more general by just allowing you to use whatever type and then attach these validations to it.
So you're sort of leveraging that to add a class that a type you've created,
Mhm.
and then a function as the output that gives you that.
Yeah.
Got it.
Yeah, exactly.
Any other questions?
Yep. My question is really around observability.
Okay.
How FastAPI approaches observability. Some people might term that logging. So the example would be you've done all of your testing of the query and template parameters, kind of happy path, all looks good. But in the live system, you're doing some synchronous or even asynchronous API calls to your API that's written. Is there any functionality that could be added in that would capture the payload going in, all of the processing of the API internally, so that you can track, the 1 in 10,000 API calls that fails? Is that even a thing? To track, basically to capture the lifecycle per API call if need be?
It's not something which is built into FastAPI. So the thing that I've seen which can do that is OpenTelemetry.
Yeah.
And the instrumentation packages for things like Postgres and HTTPX and a lot of the common Python packages, it'll automatically instrument. And then in the same way that you can hook up your Prometheus metrics, you can have OTel send or expose these traces.
Yeah. That sounds quite handy, and you'd only want to do that for the ones you want to focus on, not to log everything in a live system.
I think I think OTel has the idea of sampling.
Yeah.
So anything which is erroneous, it'll always log, and then it'll do like 1% of the rest of it, or 10%, or 0.1%, however much traffic you've got.
I'll check that out, the open telemetry. My other question is, does it have an internal scheduler? Say you want to run your API internally because it's going to call out or poll, for example, an FTP for files it's waiting to pick up.
Yes. FastAPI is built on top of another library called Starlet. And Starlet has this idea of background tasks. And so they're exposed in FastAPI in a very similar way. So but they're made a little bit more usable and a little bit more FastAPI as well. If you want a background task in one of your endpoints, you inject it as a dependency. And so you put this background task dependency in there, and say you have an endpoint you call, and then you want to send an email to the user afterwards, but you don't want to wait for the response while you're sending that email. So you can schedule a background task, and it's a fairly lightweight thing. So it'll just go onto the event loop, and it'll run. So you can also then schedule it. You could use that lifecycle function. You could start one up, something which is polling your database for something, for example, and you can put stuff in there, and then you've got that process which is constantly running, and it might pull stuff out and then go and do something else with it. Do some other kind of processing. But yeah, you've got those background tasks. I would say that I didn't mention them in here. I did put them down in my notes initially, and then I decided not to include them because I haven't used them that much. I tend to use Celery for offline processing, and the background tasks, I think, given the possibility of blocking the event loop, and given the considerations for error handling as well, I'm a little bit nervous about using background tasks for anything that's business critical, anything which has to succeed or has to definitely report when it fails and has to be recoverable and stuff like that. So I couldn't say how robust they are.
In terms of blocking behaviour, I was making an assumption that you meant things like something that doesn't come back in time or doesn't return yet, and you're waiting on a thing, an event that hasn't happened. Is that roughly what it would be, or are there categories of that I'm not really getting?
So blocking would be when you're waiting for something. So when you make an HTTP request, so
everything hangs on because you haven't yet got that update or that whatever.
Yeah, exactly. So where are we in the initial example? So you get a request coming in, and then this handler function gets run, and the first thing that it needs to do is go off and get some data, and this might take a few hundred milliseconds. It might take 5 seconds. This is something that you're not in control of, but until you get that, this can't run. It can't do anything. And if you're running synchronously, then you just have to wait. And if you've got a single thread which is serving all of your requests, then that thread's busy waiting for this at that point. So it can't do anything else. So if you have this async await behavior, then at the point that you await, I think it's magic, but the IO gets sent off, the request gets sent off, and something underlying knows that it needs to wait for that. There'll be a file handle on the event loop or something like that, and meanwhile the event loop continues to tick round, and when this client gets something back, then that ends up back on the event loop, and that'll then run, and this will continue.
Any other questions? Oh, one at the back, 2 seconds.
Just speaking to this.
Yeah, it's just on the. See that?
Okay. I'm so sorry. I came very late.
That's okay.
The only slide I saw was the summary slide at the end.
Oh, nice. Were you just going to say how good that was?
So I've been using FastAPI for quite some time, but still I think there are many areas that I did not touch. The way I use FastAPI is whether it is doing job or not for my purpose, and I leave it there. I've never went into exploring what all other features does it have.
Yeah.
So if there are any takeaways for me from this session, what would that be? Because I came in very late. You definitely can't go through all the slides again. So what will be the main takeaways for me?
Well, not knowing exactly what experience you've got, dependency injection, that's a big one for me. I really like that. If I just go back to the dependencies, so if you've got an endpoint which needs something, then you can inject that into there, and you can have multi-levels of dependency injection. So if your dependency has a dependency, then you can create an injector function for that as well. And then in your tests, you can override that dependency with a mocked version that you control, and you can just test the behavior of your endpoints and make sure that that is doing everything it needs to when the dependency behaves according to that contract. So that for me, that's the big one, and then the API docs. And I think
if you've got time after, I think you can go over it again. I think if you're not going to shoot off or anything.
Yeah.
You can do that. Yeah, if you want to stay on after, you can go through it with.
I think it's on the YouTube.
Yeah, you can be watching YouTube, I suppose. Yeah. Is there any other questions? No? Okay, cool. Well, thank you very much. That was really
Thank
good.
you, everyone.
Thank you. Stop the broadcast now. Thanks, everyone, for tuning in online. Yeah, there's no more questions on